All right, we've covered um, parallelograms, we've covered rectangles, we've covered rhombi. Now we're going to get into squares. Cool thing about squares, squares are all of them, okay? So all of our parallelograms were rules work. Opposite sides are parallel. We see that with our blue. Opposite sides are congruent. We see that with our red. Our orange, opposite angles are congruent, and they are supplementary, so they all add up to equal 180 degrees. A plus B equals 180, B plus C equals 180, C plus D equals 180, and A plus D equal 180. We also see that our diagonals bisect each other. As we can see there, AC is cut into two equal pieces at point M, and then BD is cut into two equal pieces at point M. But we can also follow our rectangle rules because we know a square is a type of rectangle. So instead of seeing these opposite angles being congruent, we can say that all the angles are going to be congruent because they are all right angles. So each one of these is going to be congruent. And then our diagonals are also congruent. So I can add that extra line right here to show that not angle, AC is congruent to BD. And a square is actually also a rhombus. So a square is a combination of a rectangle and a rhombus. So all the rules for a rhombus also work. Our diagonals are perpendicular, which means we have a 90-degree angle right there. And our diagonals bisect the opposite angles, which means that not only are these all right angles, but each individual piece, I'm actually going to use a smaller pen dot, each individual piece is 45 degrees. Sorry for taking so long, but each one of these pieces is congruent. So we've got a lot of things that we can pull from, a lot of congruency going on here. It's going to help us out a ton when we're going to solve these questions. So let's get into those. If the measure of angle AED is listed right here. Let me go to my thicker pen. AED is right there. We know it's a right angle. So we know that AED, 5x plus 5, is going to be equal to 90 degrees. I want to get x by itself, so I'm going to subtract 5. 5x equals 85. Divide by 5 to get x by itself. X equals 85 divided by 5, which is 17. Fantastic. We're on our way. Our next one, if a measure of angle BAC is 5x, so BAC, which is right here, that's going to be 5x. Well, if I look at my picture, I know that those diagonals bisect the opposite angles. The opposite angles, all the angles are 90 degrees, so it's got to be 45. So 5x has to equal 45, which means we can divide both sides by 5. X is going to equal 9. 45 divided by 5 is, in fact, 9. Moving on, measure of angle, MH. MH is going to be 8. And that's going to be this whole side over here. What is the length of AH? Well, AH is going to be a little bit different. So we're going to have to do a little bit different problem type here. This is what I'm looking for. Okay. Now, because this is a square, I know I have 4 congruent sides by property 8. So that means I can make a right triangle. The beautiful thing about a right triangle is I can use Pythagorean theorem to solve for my missing side. So I've got, because I have a right triangle here, I've got my A, my B, and my C. So I have 8 squared plus 8 squared equals C squared. 8 squared is going to be, 8 squared is going to be 64. plus 64 equals c squared. 64 plus 64 equals 128 equals c squared. And to get c by itself, I'm going to take the square root. So I've got 128, second square root 128. That's going to be 11.3. I can actually work this down to make it a little bit neater. Okay, so I'm going to use the birthday cake method, just work my way up. So I've got 128 divided by 2. 128 divided by 2 is 64. Divided by 2 is, 64 divided by 2 is 32. Divide that by 2, I get 16. Divide that by 2, I get 8. Divide that by 2, I get 4. Divide that by 2, I get 2. Divide that by 2, I get 1. And there's my candle on my birthday cake, so I can finalize this and just pair up however many 2's I have. So when I look at this, I've got 1, 2, 3 pairs of 2's. So I can pull those 3 2's out. So I've got 2 times 2 times 2, square root 2 times 1 because I don't have a pair for those, which means 2 times 2 times 2, that's going to be 8. 8 root 2. Well, if we take a look at 8 root 2, 8 square root 2, that's also going to be equal to 11.314. So either one of those would be acceptable as answers. Obviously, 8 root 2 looks a little bit nicer than that big long decimal that gets rounded, but I digress. If ms equals 3, so I've got ms equaling 3. I've got as also equaling 3 because we know that those are congruent. Fantastic. We need to find the perimeter, which means if I need to find the perimeter, I need to find this side, and then I can multiply by 4. In order to do that, we just did the same thing that we're going to need to do here. So Pythagorean theorem is going to be my friend. 3 squared plus 3 squared equals c squared, which is going to represent ma, which means I have 9 plus 9 equals c squared. 9 plus 9 is 18, equaling c squared. I want to get c by itself, so I'm going to take the square root. 18 divided by 2 is 9, divided by 3 is 3, divided by 3 is 1. So I have a pair of 3's. So c equals 3 root 2 times 1, which is just 3 root 2. Okay, the reason why I left this here, all right, square root 18, not L, square root 18, 4.2426, that doesn't look very pretty. 3 root 2, I can multiply that by 4 pretty easily, okay? 3 root 2 times 4, well, that's just 4 times 3, 12 root 2, which works, okay? I can also do, if you pay attention to the calculator, root 18 gave me that 4.2426. If I multiply that by 4, because I'm trying to do all 4 sides, I get 16.97, not 0, 971. And if we plug in 12 root 2, I get the same thing. So either number would be acceptable, but the 12 root 2 to me looks a lot prettier. There's actually going to be a shortcut that we're going to get to later in the year that will make this a lot easier for us. But for right now, this is the way we have it, and it does work.